Hello guys, and welcome back to a new episode. I've worked a lot offline. I think the last time we stopped I was working on this. So in the meanwhile, I've unlocked a few things. I've unlocked the simulated machine, the operator shade receiver, and I'm waiting for this one. Logic gates, I think we unlocked it together in the last episode. I've not unlocked anything else on the other sides. Instead, I've made a lot of small components and tried to let's explain how I'm doing things right now. So it's just one generic machine that I'm working on. As you can see, this is like one layer, this is second layer. Okay, and my first approach was to have some kind of buttons. So I just say, okay, this is the top left, and you remember we bring the pieces, the quarters directly. So with one, we have enough to feed. This one you see is 4 different. How can I say? We have enough pieces on one saturated lane to make one side, one quarter basically, times 4, you see. So this is like the top left quarter times 4, top right quarter times 4, etc. So we have we should have enough to feed the system, so that we can, this machine's throughput is 4 saturated belts of full shape at the end of the day. Okay, I don't remember if I did that online, but to these ones I've added some overflow trash. Yeah, I also unlocked the overflow from here, overflow splitter. So why is that? Is because there was too how can I say, we don't want to be bothered by shapes being unevenly used. So we make sure that they don't block eventually, and if they block, we trash them. So there may be a lot of waste in all of this, but the point is to make sure that production is not gonna block. So I spent a little time here, so just driving what color and what shape we want. So it's basically just letting pass. You remember in the last episode I said like maybe I should have a shape, different shape, a belt or something, like per lane, different shape per lane. But actually I decided the whole layer to carry the same. Because anyway, here we can command all of them. There was also a bug here. I don't know if I was online when I did that, but I noticed that this one have a limited throughput, contrary to this one. So you need to consider that you need one per machine, because the machine's gonna... you don't need one per machine. You need one per belt you're gonna work on. So because they all we have 4 different factories, painting factories. We need 300 liters times 4, so per lane, and then times 4 for the 4 lanes. And so we need to repeat this 4 times to get enough throughput for the ink. For now, we've not unlocked anything new in terms of tier, milestone. So we don't have like color mixer or whatever. So yeah, eventually I got this working, and after that we just need to add it to put a stacker. But I encountered a problem with the stacker. Sorry. I've run a lot of different tests. Is it here? No. What was it? The stacker. I think they've all been removed. Yeah, we still have one here. So, because I'm still in the middle of changing things, but because I think that I'm doing important things right now, I prefer to record it. So I've built so the stacker, I found out that you know, is gonna block if eventually when you have a shape, you may have some empty space in the shape, and if you want to have like a stack, like here we're stacking 4 corners, but what happens, like here, you see we're stacking 4 corners. This is 3 stackers, but two for 4 corners. But the problem is, what happens if one of the input is empty? What do we do? So I've had many different approaches. First I thought like, okay, let's overflow directly, because if I cannot stack, it means that there's probably nothing on the other side. The problem is that when you overflow, you're going to have potentially potential saturation in the overflow belt, and so it was messed up, and I had to clear the whole thing. I don't know if you guys were able to have a... Yeah? Is this one not connected to anything? Oh, okay, no, it's just okay, it's just something, a new thing that I could remove anyway. So yeah, eventually after that I thought about what was that? Yeah, I built a block that I called the transistor, that could be useful, but eventually didn't work. So the transistor's point is you have some so basically I was like, okay, how do we approach that? So I was like, okay, I'm gonna check this lane and cross this lane over it, and basically if there is something flowing there, then I let the other lane pass, and basically it's like a bypass. You have 2 things to consider. First, if you bypass the stacker, you also bypass the rotation, so make sure that you add it to the belt. And eventually it didn't work so well. Why was that? I don't remember why it didn't work so well. So basically it's how can I say? You see the we in like here you feed the things you that should be blocked, so it can either work in reverse or directly. So normally you have things flowing over that you're checking, and if there's things flowing, then you allow it to pass through. That's the normal one, basically. That's why I call it a transistor. So if we have a flow over it, then we allow this one to pass through. But there's a problem, is that you also need it on the other lane. So you need it on this side, and you need it on that side, and eventually I don't remember why, but I had some problems there. It works, the system worked, but it's good for not when you need to have some exclusive checking, or make sure AND gate. This one was complicated to make an AND gate with, so I ended up skipping it. But yeah, I would probably use it in the future for some other things. And the reverse is the opposite. Basically, as long as nothing flow, then this one flows. So it's like, when we use the reverse, it's like an exclusive. You could have an OR exclusive or something like this. So it's still a good component I'm satisfied with, but I'm not using it now. And after that, I also had some problem with belts that stack too much. As you can see here, like when we because these belts are so fast, and that eventually the machine is just handling normally 4 lanes. I mean, how can I say? Basically 4 saturated physical lanes, but this one is 4 times faster, and so it ends up stacking a lot of shapes. And whenever we change the shape to adapt it to the new one, whenever the shape is stacked like this, is not good. Actually, I wanted to this one I probably should put one here as well, so that we always have no buffer. We don't want to buffer shapes. We want to have, like, how can I say, we want these belts to really be unstacking elements there. We don't want any buffer. As soon as we change, we want it to be very fast, to change very fast, okay? Eventually, this is not a big problem for shapes that will last forever, like the ones that are milestone based. But for the ones that we're gonna migrate slowly, then we will have delay, a strong delay of few minutes each time we change the shape. That delay is gonna narrow down as we increase the speed of the belt. But as you can see, it's 25%, still a lot. Eventually we reach maybe two, 3 times faster, and so the shape change delay and will get smaller. Yeah, so why did I started to record? Because so to be honest, I'm not caring much about optimizing and getting the thing as small as possible. As you can see, we have a lot of empty space. I'm working on this block now. Why? It's because I developed here a shape detector. Whenever you release you get the simulated machine, you get access to at first I was like, okay, but how can I get the corner or something like this? So you have the shape here that you can that is an input signal, and then here you have an unstacker. On the right side you will have the rest of the stacks, and on the top is output the topmost shape. Okay, so this simple thing is a shape and color detector and layer based. So it means that, let's say I want the second layer, so from the top, my only concern for now is that we unstack and we don't know, how can I say, we would need to reverse in the opposite direction if we would want to determine the, how can I say, we cannot count from the base. Like 1 cannot be the base, 1 will be the tops, the top stack, you see. So if this shape that I input there, you can configure it here and copy paste. So let's say I want the second layer. So here I can put 2 is the layer, okay? And what it's gonna do is that it's gonna compare it to 1. So each time you see we unstack a piece. So here there's the first stack here. So if I choose to get the first layer, then I'm comparing 1 with the number. This one is gonna turn not work. So it's not gonna work from the signal is not gonna pass through. This one is a transistor gate. Okay. So but 2 here is compared with the one I just input, and so this stack, the second stack, is gonna pass through, okay, and then it's gonna go up all the way for analysis. This is the second stack as we want, okay, and when we go up, we have this tool, the analyzer, shape analyzer. So it's giving you the top right color and shape. It is very powerful. At first I thought like, okay, maybe I should just cut. I need to cut the left side, cut the top side, rotate and things like this, but actually no, you get the color and the shape immediately. So the only thing you need to do is rotate whatever you're interested in, so that you get it. Unrotated, it's gonna go out here. First rotation, second rotation, third rotation, and we get here we get the 4 different shapes and colors here, as you can see, blue and square. So this is the top right, this is the bottom right, this is the, or the opposite. I mean, I don't know, depending on the rotation. It's not a big problem. So eventually you get so you get your shape, and now the same as what I did here, we have a corner selector. So if I want the bottom right, actually right now this is the selected one, is going to be the top right, and it's gray, and it's gray square. But if I choose 2 here, then this one is the corner selector. The corner is the bottom right at this time. So you see it's a blue square, okay? And then this signal is going to be compared on the second layer with all the shapes available in the game. So some of which we've not found so far. These ones I also prepared for it. So circle, square, star, and W, and then this one is P, C, U, X, and Y. Okay, and exactly the same on the second layer for the colors. We have uncolored, red, green, blue, cyan, magenta, yellow. Looks more orange to me, but yellow, white, and black. Okay, so that was the component. That is so I've done that component now, so I know how to drive based on what I detect. And so eventually, you know, we don't have the color mixer or whatever, but this area here will be reserved right now for the day we can create additional colors and drive additional colors. So at that time, basically it's just, I think magenta, for example, will be red and which one? Yeah, I reversed, that's why I didn't see. Okay, let's say yeah, magenta, it should be like maybe red and blue. And so we just if this one is detected, we just need to turn on at the same time two pipes that will go to the painter and prepare the color for it. Okay, so that's it. So now, right now, because we don't have any painter or whatever, I'm going to delete all the manual controls that I have. So right now I've done the red. This is uncolored. And so uncolored is here. I will optimize the space eventually later, but so this was the uncolored control. Now we have the green that is on an extra layer. Actually, maybe I should consider using the... Okay. Yeah. That's why it looked strange. So let's stick to how we did before. Okay, so this is the uncolored. Is it correct? No, it's not correct because I've linked the signal itself instead of linking the... I've linked the input instead of linking the output. It's better. Okay, now we have the green to connect. The green should be connected there. Here. And now we have the blue. It's gonna be a bit spaghetti, huh, but who cares? The blue, right. Now all that remains is connecting the shapes. This is the circle. We can just press like this. All right. Square. Now we go for the stars. Let's remove. Why? There's something under. So why? All right. Just missing. And finally, the W. Why? Okay. All right. Time to test all this. This one's valid. Okay. Reminds me of an old game called Battleship. When I was young, I was playing. So what I'm going to do now is so this one is the topmost shape. So it's 1 1 1. It's the top left. So it's the top right, sorry. So it should be a red square, a red star, sorry. We get the red and we get the stars, and we're getting red stars eventually. And we move all my sandbox down. Ah. So now we're going for still 1 1, but this one is the second corner. So we should have a yellow, a green star. Okay. This one's gonna be 3. So compressing it back into smaller. Actually, I should use another example. We're not much interested in this one. Let's put this one instead, this symbol instead. So yeah, the only pain here is that after that we still need to pass all this, but I'm suspecting, oh, we got a lot of money here. Wait, let me see. Maybe wires, maybe this one. Let's see. Unlocks global wire transmitters, allowing you to transmit signal globally over different channels. I'm nearly sure that we can do that now. Let's see. I got a lot of money. I don't know which one. Let's see how it works, that transmitter. Sends logical signal globally on a control channel. On a control channel. Okay, show me. You can use global signal transmitter and global signal receiver to transport signal over large distances. The global signal transmitter accepts an input signal and a channel signal and broadcasts the input signal to the specified channel. An input signal and a channel signal, and broadcasts the input signal on the specified channel. The channel signal can either be a shape read or a number. Input signal. Global receiver accepts the channel signal and outputs any shape that is sent to that channel. Receives logical, okay. Okay, I see. Let's see how it works. Signal receiver. Operator. Operator signals. Globally, okay. So is the opposite? The number is like the channel. Oh no, this is only the operator. Global signal receiver. Okay. So I put myself on signal 10. What do I get? Okay. Understood how it works. And I'm very satisfied with this. So this is the first machine on channel 1. Let's emit that one. This one is configured on channel 1 as well. Okay, it's taking everything. All right, exactly what I wanted. Okay, the channel and the shape. And then they're all doing the same. This one. Advanced. To shape corner builder. Figure 2. Layer 2, which is the bottom layer. Once we have a stable machine, I'm going to repeat the whole machine several times so I can have several shapes in parallel. Oh, why is it 4 there? 4? Okay. It's because I copied the other one. Layer 2, here it's 1. 2, 1. 2, 2. 2, 3. And 2, 4, correct. Okay, so normally we're able to do double layers with this system. I'm going to start increasing. If this one works, we're gonna go for more than 2 layers. Let's see. So that's the top layer. It's gonna be added over the other one. This layer, what are we getting? And back to the stacker. So what I did there is just have a detection system on boss. So the same, I didn't compact things, didn't try to make it too small. I didn't even use the third layer much, I think. So I just wanted the things to be clean. So this one have the ability to, given a slight delay, it's gonna detect that things are arriving on the other. Like if either of them have things coming, then it will not bypass. That's why it's always green here. This is like the things being stacked, and under is the things, the base for the stack. But if I'm not mistaken, or maybe it's the opposite. No, it looks correct. And we have many conditions, so unless the belt is really unsaturated, we should never be mistaken there. I know it's a bit overkill, but I really wanted to be safe. And yeah, it ends with the end gate. So it's either all of this or all the bottom, and then you see the end gate. The base is more flat, like the real one in electronics. So it's an end gate. We need a minimum, we need boss to have, if boss, like if the base and the top are present, then we're going to move to the stacker. If none of them is, if one of them is missing, sorry, then we're gonna bypass the stacker. And this is the bypass lane. Currently the shapes we're making have no holes. So yeah, we're getting our shapes. This one is fresh, so I still need to make sure that there is no mistake with like the rotation or something missing. But as far as I know, the post rotation is correct. The other one is correct. It just takes some time to assemble. It says that different shape. It's true. And you know what? Here. So here is a filter, and we can add the receiver there. So this one is yeah, let's just copy paste the receiver we have there. It's okay, I will fix it. Probably. We'll let this shape pass. I'm wondering if the rotation matters. I'm afraid it may. We'll see when they start to arrive. What the hell is that? We don't need any rotation. Just need it to pass through as is. Ah, wait. This one is no rotation? Okay. Makes sense. Yeah, it's flipped. That's why. Third one. First one. Third one. First one. Third one. Okay. That one doesn't have the overflow capability. So maybe I should bring it to it. Just pass through. No rotation. Ah. It's flipped as well? Okay, just pass through. Machine view. Let's see what to get with this. Vortex input, we don't care. Platform capacity, we still okay. Train speed, still okay. Train capacity, I think this one is good. Because is 200% capacity. What else could we be interested in? Access 3, I don't care. 3x3 maybe later. Freight wagons. Unlocks freight wagons, loader and unloaders. Okay, for now I don't see why we need that. Spacer wagons. Okay, waste stop. Transfer platform. Unlock space station spacers for building stops with gaps between loaders and unloaders. Primary colors. Okay, we get more trains. Secondary colors. White color. Okay, in terms of investment, I'd say improving the train a bit. Speed multiplier. Speed multiplier would be good as well. Normally the new train capacity should make things easier already. So, what shape do we get? Most of them go to trash. What's wrong there? Let's see. We get... Okay, it's pinned to the bottom right. What about this one? Spin to the bottom right as well. You should be correct. Yet they're not. Yeah? No, okay. Huh? Ah, they are being stacked in reverse. They're being stacked in reverse. Okay. It's the... Okay. If I flip it, then... It's so powerful to be able to flip like that. Okay, should be better now. So my only concern is the fact that it's the base that is being rotated. And because it's the base that's being rotated and not the top, then if we have a hole, maybe we're missing a rotation. Eventually, let's say it goes inside. I mean, yeah, maybe I should reverse and make sure that it's not a big deal. It's just about changing these two. It's not really not a problem, but especially since we have so much space. Let's say, because if we rotate the base, there's a difference in how the next base will enter. Let's say we add this one here, and then the base gets rotated. Okay, we add it there, and then it needs to enter the next one, get rotated, but then the next one have no stack over it, so it gets rotated again. I mean, the previous piece that was on it, because there was a base, was rotated. But if there was nothing, it would pass through and not be rotated. I think we will have to reverse what we rotate. It should be the thing that's getting stacked that would be rotated. And the rotation would be, yeah, would probably be better and make things cleaner. For now, let's continue with this one. And does it get trashed? Still trash it because it's not in the good orientation. They're difficult, huh? Okay. Okay, what we're gonna do is first of all, I forgot to connect this one. So maybe that's the problem. And now? Still doesn't like it. Because, okay, I understand it's not a problem to me. Alright then. I'm gonna have a push button here. Allow rotation. So this button says that it's rotation independent. It allows us to here we need a transistor. This one will only be on, what's this? If and only if this transistor says it. Then is the opposite. We need a knot. If this one is on, then that's a rotation independent. I'm gonna put a label here, a label. Independent, rotation independent. Okay. Okay, so rotation independent, but I just need to make sure that the shape is correct. That's the signal, and so we need to rotate it 3 times plus the signal itself. Hmm. Interesting. So I would need... Hmm. Because it's being compared based on logical signal. Let me see. Is it the one we're getting? Okay. Can we send... My question is, can we send this the right signal there and it just let it pass if it's the good one? Okay. So, and what about this one? So this one is non-rotated. Okay. And it only let it pass if it compares to the right one. It's going to compare to the signal I send. But I cannot send several signal. So each one of the lane, we need to have 4, if it's rotation independent. I'm going to work on another one. And for now, let's just let it pass to finish the... Right, it should be fine. So it's like four different chances. Eventually, if it fails, it gets to the trash. Otherwise, no need for the compare, but I need the rotated signals. Because the compare is done at the machine. The first one, second one, third one, and fourth one. So if it's not independent, let's make a little space. So let's see what's going on. Starting to have the shapes arrive at the main hub. Speed is pretty good. So my question is, I let this one pass. If I'm rotation independent. Where's the shape? Testing some fancy stuff. Probably much easier. I mean, there's probably a much easier way to do the same thing. That's the entrance for the shape. Oh, come on. There's always something, but I probably did it too complicated. Was not necessary. It's a bit overkill in my opinion. So what it means is if it's rotation independent, you see we have the 4 rotations. If it isn't, the 4 the 4 pushers will have the same condition. I'm gonna move all this logic. Should I keep it at the top? Maybe it's still okay at the top and we walk under. Let's fit this for first. Okay. I'll just fix it if we're blocked somewhere. Wait. Wait, if it's valid, if it's not valid, then it gets pushed away, right? So if it's valid, it passes through. So this is not correct. If it's valid, it reaches the main belt. If it's not valid, and it still needs to be valid. If it's valid, it reaches the main belt. Damn! This makes things a lot more messy. We have a bit so we can see what we're doing. Just need to reconnect the signal. All right. So here we see much better. Let's clean up the base as well. So let's do it for one and then consider about the rest. There's all of these pipes there. Okay. So if the shape is recognized, it goes straight and it reaches the main build. Otherwise, it's not the right one. It's this one we're interested. Okay. So if it's the correct shape, it will pass through and then finish. Otherwise, it will get kicked out for another attempt. And eventually we reach the trash. If we couldn't find it. I don't know if there's a better way to do this. I don't like it much because it takes so much space. Could I like flatten it this way maybe? Make it straight instead. Like instead, move it back up. Actually, this one is the validated one. So the fail goes inside. Actually, you know what? Why should we care? Of course we can fit it inside. But why should we really care about this? My point is, maybe just... Okay, I can still try, but I'm not gonna push it. Actually, we've got the third layer to just bring everything back. Damn. So I need to connect the signals there. Okay, let's try it as a challenge. Okay. All the signals are connected. connect the input belts and the output belts. Why? It's good to me. With belts connected. Two. Just a second. All right, so and the final. Well, I'm pretty impressed. Didn't see it would work. Okay. Let's see how it goes. Save this one first. So it's not rotation independent right now, and so it should fail all the checks and end up in the trash. By the way, where's the trash for this one? It's also here. Yeah. Okay. Let's see. Pretty stylish. Still had a little space there in the middle, but overall, a very good piece. So, it's trash, 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 trash. They all failed the test. Right. Nothing get blocked as well. Okay. Now, magic. Magic. Nothing go to the trash anymore. Yay. Alright, this part's validated. So it used to, what was it? It's did it have a name? I don't remember. I'm not even sure I saved this one. Transistor, stack 4 shape filter. A shape filter maybe? Yeah. Wow. I've come a long way. Shape filter. Only thing is this shape filter doesn't support non. I will keep the original in case I only need to let one specific shape pass. The way that I can set it by hand. I could have something here to do it. Like instead of using this signal as input, I use another input and I choose which one I want to use. It would be possible before I save it. Maybe I could think of a way. Could I use like a OR gate? So like this basically. And then if I use the OR gate, it's okay to use the OR gate. The OR will output a logic signal, so we lose the information. If this one exists, we want to pass this one. Select some kind of transistor gate. actually is the opposite. Let's see if this one exists. We'll let the other one pass. If I put it at noon. Okay. So if this one is not null. Okay, it will take. Okay, we just need a NOT gate. Okay, so if I remove the shape here, it will continue to work. Damn. Otherwise, so if I put a shape here, it's overriding, right? See you, see you, see you, see you. Yes, it's there. But if I reset it, then it's the other one that's being used. So it's an override. Rotation independent. So that we see a little better. So that's an override. That's the channel. Rotation independent. Okay. Let's save it. One. Shape filter. Rota independent. Okay. Basically, what we see here is all the shapes that are accepted. Trash, trash, and trash. Okay. So I think next episode we're going to rework the stacker so that the rotation applies to the stacked and not to the base. So it's gonna be more convenient to freeze the location of the pieces. Basically, they stacked once and for all in a specific direction. And we don't expect, for example, yeah. So it's not going to be very hard. It's just going to be about swapping this one and the one at the top, basically. No, it's going to be about yes, actually, yes. It's just gonna be about plugging the ones that are supposed to go over with the ones that are on the ground. So the ones on the ground. Actually, maybe I can do it now. Let's see. Claim. top 16% worldwide. Okay. I got a lot of beats. Just found out that we get a lot from we got really a lot from these last things that we've done. So since I'm here, 3x3, I want to commit on this. Let's buy the little things that I may be needing. Speed multiplier, 25% is still good. Train speed, we don't care. Fruit tank, let's buy the cheap stuff. Just get rid of this. Freight wagon, wagons, transfer platforms. Okay. So let's fix the stacker now. I swapped everything. So that's the base and that's the stack. So wait, it was better in the other direction, I think. There's still the thing getting stacked. No, I was correct. So now the thing getting stacked is gonna be at the top. So I can either reverse it here or reverse it there. Either way is possible. Yeah, just reverse it here. 4 coming. It's 1, 2, 3, and 4. Here we are. So this one I'm going to call it 4. Stacker rotated. No, stacker up rotated. Up rotated. Save, and it's gonna replace the stacker, this one. replace the other one. Stack 4, stacker up rotated. Yeah, because there was something already selected. So at the top is the one getting stacked. The bottom is the one. Okay. Okay, so everything. So we get the top right corner, if I'm not mistaken. This one is gonna be the top right, but it's unrotated. So most of the shapes we'll be making will be rotated a bit to the. Let's see. I could just add a stacker here, like we don't care. So it allows me to choose the rotation here. And because it's auto bypass, it's gonna work immediately. Oh, funny. Wait, what? It's like not the new one, I think. Where's the new one? Stacker up rotated. Is this one? It's like it didn't work. Let me delete all that. Okay. I'm just going to reverse it, but if I reverse it, then the stack is no longer at the top. Okay. Just a bit too tight. Fuck. I'm not a big fan of what I'm doing. I will refactor this once we have a final machine at some point. Huh? More down. So now if we, so it's the top right. So because we work with the top left reference, we need a clockwise rotation. No, this is counterclockwise. I want it to be the top right. Yes, correct. This one's going to be a 180. Sorry. Okay, and this one will be the top top left. There's wait, 180. Okay, bottom left for this one. So it's this one, I think. Bottom left piece, and the last one doesn't need any rotation. Fourth, second. Because I swapped it, so yeah, 180, 180. So third, first, second, fourth. Correct. Let's bring all of this there. Alright, this is the main, and then This one is to be added to this one. No, not at all. Sorry. My bad. First we do the second shape, and then we finally edit. I will use the new adder. So the one coming from afar, this one is the topmost layer. So it needs to be the rotated one. So like this. It will be the rotated one. And this is the under layer. There was some kind of filters there. I still need to double check this. Okay, this one is plugged on which one? Channel 1. And it's okay. Shape independent. Okay, let's stop the video here. I'm going to continue in next one. Next one, we're gonna double check this, and if everything goes according to the plan, I'm gonna expand it to 4 layers, and we're gonna start to duplicate the whole machine so that we can mass produce all the rest. Thanks for watching.